Assalamualaikum warahmatullahi wabarakatuh. Good day again. So we meet again. Just now we already see up to infinite slope analysis this slide. Okay, infinite slope analysis, and we just solve one example. So this question usually being asked in the final exam and test. Okay. Alright, so another one condition for the linear failure line or linear failure plane is a finite slope. Finite slope. So you can see here, this is a finite slope with a height of h. So it has beta angle for the embankment and theta angle for the final failure line, for the failure line or the failure plane. Use the as a pointer. So height, beta, theta, okay. And at the, let's say at the middle of the failure line. So if we interested to check for the factor of safety, so we can check what is the normal stress, which is related to the weight of the soil, and also what is the resisting force. So here, resisting force, and also another one, T is the also the induced force. It comes from the weight. Okay. So this is finite slope because the failure line stop at the toe of the slope at A. Finite slope because the failure line is stopped at the toe of slope at the A point. Okay, so from the figure, first and foremost, we usually need to calculate for the weight of the soil, ABC. So just now we have a embankment with the slope at toe A, B, and the failure lines we assume occurred here. So C. So for the weight of the slope, so we can let's say I extend a little bit more the slope. So we can have this like a triangle. So half of the unit weight of soil times the L, okay, times the L, the base of the triangle, and also times the H, the height. Okay. Can be calculated like that with the sine beta theta divided to the sine beta. If you still remember beta and theta is the angle. One is angle of the embankment beta. Another one is the angle of the slope of the failure line. So resisting force Rs, which is very important, is the cohesion of the soil times the length with the weight cos theta tangent phi of the internal friction angle. And the force that will cause the failure is T, a part of the weight. So weight sine theta. So the factor of safety can be defined either in the total stress condition here or effective stress condition. C prime with the pore water pressure, right? And how to check the critical condition in order to get the critical height. Similarly, we assume factor of safety 1 will give critical condition. So the critical failure plane will become theta beta plus the internal friction angle divided by 2. So by substitute the theta, the angle of the failure line, if we could draw the embankment again. So this is failure line, the toe. So theta. So substitute the theta with this one, so we can get the height, critical height like this one. Alright, some of the finite slope problem being asked when they have two types of soil. The upper layer and we have another layer at the bottom. And some of the principal valid, if we have two layers, the upper layer is assumed to slide along the interface between the two layers. Means in the middle of the transition of slope 1, soil 1 to soil 2. So sometimes failures occur and stop here. So the finite slope stopping here, wedges condition is only at the top. But sometimes it could go up to both layers. So it depends on the situation, so on the condition. So here is one of the example. Let's say we have a slope. We want this is the original slope. Original slopes is outside here. Original ground surface. Okay? But we want to cut the slope in the ratio of 1 to 5, 1.5 to 1. Okay, here. So this is the cutting new slope. So it has a dip at 16 degree, means the failure line occurred here, failure lines. So by knowing the unit weight, let's say we get the unit weight from the data, from the laboratory data, and the shear strength parameter C is 15, P is 20. What is the effective stress FOS? Okay, what the FOS in the manner of effective stress? So of course, like I mentioned just now, first we need to know the weight. We need to calculate the weight. Either we want to use the triangle area. Yeah, we can assume like a triangle here. Okay, so we need to know the length here up to the toe, the length of the failure line. So it is not given, it's only given 85. But it also give you the height, or they give you the height, so it's okay. And then once you know this one, weight, length, you can solve for the FOS. Okay. So remember the equation is given here. You choose the effective equation which have the for water pressure. Consider the for water pressure on water table here. So we can solve. So here is the length. I believe this is height and gamma of the soil. So length here calculated again using this one, and for water pressure, calculate the for water pressure. Just use estimation ZW, the height of water equal to 3 meter from 0 to 3.2 actually. So take the average. By doing that, we can have a range of value actually, FOS, but just calculate, we can get 1.42 of the FOS. Alright, so the next one is a nonlinear method. So I think I'll stop here for this video. So we meet again in next video for the, I believe, third part, the part 3. Assalamualaikum and good day. See you again.